Welcome. At the end of this video, we will not have any challenge solving problems on Snell's law. So we'll be looking at a couple of questions in this video. So let's start. The diagram above shows an incident ray AO inclined at an angle 50 degrees. So you can see it right here, 50 degrees, to the interface CB. The refracted ray OB is found to lie along the surface. What is the refractive index of the medium X with respect to Air? So you can see the medium X here. This side of this plane is the medium X, while this side is Air. So what they're asking for is what? The refractive index of X with respect to what? Air. This is what they are asking for. So how do we go about it? First of all, according to Snell's law, N1 sine theta 1 is equal to N2 sine theta 2. Once you have this formula in your head, you can solve any question on Snell's law. So what is my N1? Let my N1 be my refractive index of X, and let my theta 1 be the angle to the normal on the side of the medium X. So what will be that angle? That angle, this is your normal. You can see your normal here. This is the line, this is your normal. So the angle to the normal is what? 40 degrees. So therefore my theta X or my theta 1 will now become what? Now become 40 degrees. Then my N2 will now become what? The refractive index of Air, while my theta 2 will now become the angle on the to the normal on the part of Air. So you can see the normal, then this is the angle to the normal. Remember that outside the air, the ray, what? They say the refracted ray OB is found to lie along the surface. So you can see it's lying along the surface here. So this is it. So this angle 90 degrees. So therefore the theta 2 is 90 degrees. So what are we looking for? We say we are looking for the refractive index of X with respect to Air. So Air will be under. So basically what that looks like is NX sine 40 degrees is equal to NA, that is refractive index of Air, sine 90 degrees. So therefore NX over NA, once you divide both sides, so you bring NA down here, you bring sine 40 down here, so you now have is equal to what? Sine 90 degrees over what? Sine 40 degrees. So this is the answer. Let's see. Therefore our answer is A. It's as easy as that. So let's look at the other questions. Still on that diagram, they can ask you what is the refractive index of Air with respect to the medium X. What do you do? A similar thing. This time around, they're asking you for the refractive index of Air with respect to the medium X. So therefore, what you simply do, I'll show you two ways. Once again, we'll say our N1 sine theta 1 is equal to what? N2 sine theta 2. So what is my N1? Here's my N1 once again be what? Your medium X, and my theta 1 be what? My 40 degrees. Then N2 is what? Refractive index of Air, and theta 2 be what? My 90 degrees. So therefore, using the formula, what do you get? You are looking for NA with respect to what? With respect to NX. So if you have to do this, you have NX sine 40 degrees is equal to NA sine 90 degrees. So NL over NX, you carry NX here, by the time you divide both sides by NX. Then you carry sine 90 here, sine 90 degree divided by sine 90. So NL over NS is equal to what? Sine 40 degree over what? Sine 90 degree. So you can see that is the answer. Another way, you can just do the inverse of the refractive index of X with respect to air. So once you do the inverse of that, Nx over Na, what you get is what? Is the refractive index of air with respect to X, and that will still give you your sine 40 degree over what? Sine 90 degree. If you don't understand, you can pause the video and make sure you grasp it. So let's look at two more examples before we go. So you can pause this video and try it out with the formula, but let's look at it together when you are done solving it on your own. A ray of light traveling inside a transparent plastic block hits the upper edge at an inclination angle of 35 degrees. So first I want to draw. So solution. They say a ray of light traveling inside a transparent block hits the surface, the upper edge at an inclination angle of 35 degrees. So the ray goes like this, then hits the edge at an inclination. So this is inclination here, 35 degrees to the surface. If the light ray enters into the surrounding air and skims perfectly along the surface, so once again it skims perfectly along the surface. So this is what we are having. So these are our incident ray in the what? In the transparent plastic block. So this is your plastic block, while this is what? Air. You get perfectly along the surface. What is the refractive index of the plastic block with respect to air? So we are finding the refractive index of the plastic block. Let me call it P. So P with respect to air. So we draw our normal. This is our normal. So therefore this angle here is what? 90 minus 35, which is 55 degrees. So let's solve it. So using Snell's law, we have N1 sine theta 1 is equal to what? N2 sine theta 2. Let's call our N1 what? The refractive index of the plastic block, and sine theta 1 will now become what? This 55 degrees. Remember that the incident angle is what? Is the angle to the normal. So you must make sure you are taking your angle to the normal, not this inclination angle. No, the angle must be to the normal. So that is sine 55 degrees is equal to, what is my N2? My N2 is air. Then once again this is 90 degrees. So sine 90 degrees. So what are we looking for? The refractive index of the plastic block with respect to air. So that means we are looking for NP over what? NA. So NP over NA will now become what? Sine 90 degrees over sine 55 degrees. So that is your answer. Sine 90, sine 55. This is the answer here. So lastly, let's look at number 4. So once again, solve the equation, then come back to look at the solution. So a light ray traveling through a dense diamond medium approaches a boundary line with an upper layer of water. So take note, this time around we are looking at the boundary between a diamond and water, not air. And you give us the refractive index of water to be 1.33. If the ray strikes the boundary at its critical angle, the critical angle is the angle where there's total, where the refracted ray is 90 degrees. You see, causing the refracted beam to emerge directly along the interface surface, which expression correctly calculates the refractive index of diamond. So once again, let's say this is our diamond. So solution, this is our diamond, and this is the water. This side is full of water. So basically, you say the light is coming from diamond, and when it hits here, it moves along the surface in this direction. Pardon my diagram. So this is our normal. So this is 90 degree. You see what? It is at an inclination. If the ray strikes the boundary at its critical angle, so the critical angle, the angle of incidence here is what? Your critical angle. This is your diamond, and this is what? Water. So they're asking for what? The refractive index of diamond with respect to water. So therefore, once again, we have N1 sine theta 1 is equal to N2 sine theta 2. Whereby my N1 is what? My N1 is my diamond, refractive index of diamond, and my theta 1 this time around becomes what? My critical angle, which is theta C. Then my N2 is what? The refractive index of water, which is N water, and they have already given us the refractive index of water to be what? 1.33. So I come here and write 1.33. Then we have my theta 2 is equal to what? 90 degrees, because we say that what? There's, it strikes the boundary at its critical angle, causing inverted beam to emerge directly along the interface surface. So that word tells us that the angle is 90 degrees. Okay, so I haven't said that. What do we have? We are looking for the refractive index of diamond with respect to what? Water. So what do we have? We have ND sine is equal to N water sine 90 degree. So ND over N water is equal to what? Remember, okay, ND over N water is equal to, or rather, pardon. So remember that we're already given N water, so therefore we have ND sine theta C is equal to what? 1.33 times sine 90 degrees. So therefore ND is equal to what? 1.33 times sine 90 degrees all over what? Sine theta C. So take note, what we are looking for is what? Is your ND. So that is the refractive index of diamond. So let's see what our option here will be. 1.33 sine 90 times all over theta C. So this is our answer. Thank you very much. If you enjoyed this video, make sure you like, subscribe, and follow for more. We'll be solving more questions. Alright, take care.